thanks for watching. And in today's video, I would like to show you simply that null space is in fact a subspace. Is a subspace, and we'll see a subspace of what? Let's first of all discover what it is a subspace of. So let's take the matrix, 1, 2, 3, 4, 5, 6. It's a 2 by 3 matrix. The null space, by definition, is the set of vectors where AX equals 0. In this case, let's look at A. Well, we have 1, 2, 3, 4, 5, 6. And this is our X, and this is our 0 vector. Well, X, in order for this to make sense, it needs to be a vector with 3 components. So here, X is a vector in R3, and that's precisely the number of columns. So in other words, if A is a m by n matrix, the null space is a subspace of Rn. N as in input, or as in null space. So X in Rn, such that Ax equals 0. And so let's show the thing I wanted to show. So claim null space of A is a subspace of Rn. And at the same time, let me remind you what a subspace is. And by the way, this has nothing to do with matrices really. This also works for more abstract linear transformations. But for now, let's just keep ourselves to the world of matrices. So, what do we need to show? We need to show that the 0 vector is in null space of A. Okay. Remember what the definition is. The null space is the set of vectors such that Ax equals 0. The question is, can we let x be 0 here? In other words, is A times the 0 vector equal to the 0 vector? And you hope it is. In other words, if we take 0, 0, 0 here, is this matrix times the 0 vector the 0 vector? Yes. And by the way, strictly speaking, those are 2 different 0 vectors. That's the vector in Rn, like R3 here, and this would be the 0 vector in R2, okay, Rm. But anyway, it is true, so 0 is indeed in the null space of A. The next thing is we have to show if, let's say, x and y are in null of A, is x plus y in null of A. So this is the second requirement of being a subspace. If you have 2 vectors in the subspace, is the sum still in the subspace? In other words, if x and y are in null of A, is x plus y still in null of A? And at this point you might be stuck. It might seem very abstract. For those abstract questions, make sure to use the definition. So the definition of null space is simply Ax equals 0. So what we know is that Ax equals 0 and Ay equals 0. And I forgot to say, suppose x and y are in null of A. And what we would like to show is ideally that x plus y is in null of A. So we would like to show that A of x plus y is that equal to the 0 vector. Well, let's see. A of x plus y, you can FOIL this out. You get Ax plus Ay. But Ax is just a 0 vector. by assumption here. AY is the 0 vector by assumption. And 0 plus 0 is indeed the 0 vector. So you see, A of x plus y equals 0. But again, what is the null space? The set of solutions of A of blah equals 0. Well, x plus y is a solution of A of blah equals 0. So x plus y is in null of A. Okay. So indeed, we assume x and y is in null of A, and we showed x plus y is in null of A, which is exactly what we wanted to show. Lastly, we need to show if x is in null of A, then Cx is in null of A for every C. In other words, suppose x is in null of A, What does that mean? That means, what does that mean? Ax equals 0, and we need to show that Cx is in null of A. So the question is ACx equals 0? Well, let's calculate this. ACx. The cool thing is, constants you can pull outside of the matrix. So the C you can pull out, and you get CAX. But remember, AX was 0. So we get C times the 0 vector, but that's just the 0 vector. Any multiple of the 0 vector is the 0 vector. So Cx also solves A of blah equals 0. So Cx is in null of A. So indeed, null of A satisfies the 3 requirements of being a subspace. So indeed, null of A is a subspace of Rn. And that's why null of A is very interesting. That's why we care about this. It gives us, interesting examples of subspaces, and also sort of to study it on its own. Yeah. So it's not a random space. It is a subspace. That's nice. All right, so I hope you like this little proof and this linear algebra extravaganza. If you want to see more math, please click like and make sure to subscribe to my channel. Thank you very much.